All right, you have made it to the last and final content video for Calculus 1. Congratulations. We are at definite integrals. Now, the only thing that changes between indefinite and definite integrals is we also need to change our bounds to be in terms of u instead of in terms of x. So what I mean by that is on this first integral right here, I'm going to let u be equal to this inside piece, 1 plus 2x cubed. Now, the next step we'll do is find our du piece, 6x squared dx. I notice I have an x squared and a dx here, but I do not have a 6. So I'm going to move this over by division over here. Now, the last thing that we need to make sure that we do is also change our bounds, because these are in terms of x based on our integration variable right here. So when x equals 0, I'm plugging into this formula right here, u must be 1. And when x equals 1, and I plug that in, u must be 3. So I'm going to change this integral completely to be in terms of u. I'm going to change my bounds to go from 1 to 3. U is raised to the 1/5 power, or excuse me, to the 5th power. And then in place of x squared dx that's left over, I'm going to put 1/6 here on the outside and du. So now I have switched everything in that integral to be in terms of u's. When I take this antiderivative, I have 1/6 u to the 6 over 6, but that means that I would end up having 1/36 here, because a 6 times a 6 would be 1 over 36. And these bounds are in terms of u, so I write from u equals 1 to 3. So this is 1/36 times whatever 3 to the 6th is, minus when I plug in 1, and I'm just going to leave it like this for now. All right, let's go ahead and do this one here. Now my u is going to be my exponent, so I'm going to let u be equal to 4x squared plus 3. That means that du must be 8x dx. I see an x dx here. I don't see an 8, so I'm going to move that over here. Now again, when x equals 0 and I plug that in, u equals 3. And when x equals 1, it looks like u is equal to 7. I'm plugging into this piece right here to find those new bounds. So I'm going to integrate from 3 to 7, e to the u. And then in place of x dx, I'm going to put in 1/8 du. 1/8, the antiderivative of e to the u is just e to the u from u equals 3 to 7. And so I get 1/8 e to the 7th minus e cubed, and that's going to be my final answer. All right, let's look at this last one that we have here. Now, if I try to make u be cosine theta, which is my original thought, I don't have a sine, so that's not going to help. Like, that's not going to get me anywhere. So the next question becomes, can I rewrite cosine squared so that I can then find this integral? Well, cosine squared is 1 minus sine squared, but that doesn't really make it any better, so that's not going to be helpful. But there are some power reducing formulas that will be helpful. So if we look those up on the internet, or if you've had them memorized, cosine squared is the same as 1 plus cosine 2x over 2. So I'm going to rewrite this as the integral from 0 to pi over 2 of 1 plus the double angle of cosine over 2. I'm also going to go ahead and factor out this 1/2 because I just think it's going to be easier to see that way. All right, and so I'm going to do a u sub here where my u is actually just going to be 2x. So u is equal to the inside of the cosine function. Du is 2 dx. Now, be careful because there is a 1/2 here and that can get really confusing, but I don't have an extra 2 outside, so I need to move that over. All right, let's go ahead and fill in the pieces that we know. I need to change my bounds. 1 doesn't change, cosine of u, and then in place of dx, I need a 1/2 du. All right, when x equals 0, u equals 0, plugging in here. When x equals pi over 2, u equals pi. So I'm going to go from 0 to pi. And now this is an integral I can take the antiderivative of. I'm going to go ahead and take this outside. I have 1/4 on the outside here. Now I'm integrating with respect to u. So the antiderivative of 1 is u, plus the antiderivative of cosine u is sine of u, from u equals 0 to pi. If I plug in pi, I get pi plus the sine of pi minus 0 plus the sine of 0. Now this over here ends up all being 0. Sine of pi is also 0. So my final answer ends up being, oh my goodness, pi over 4.